Hi, everyone. My name is Shomo, and I am very happy to be here and talking about a special topics course that I am going to be teaching next year. Uh, this course is called Unconventional Computing, and it's looking at sort of unconventional approaches in artificial intelligence, especially approaches that have been tried in the past, but perhaps not with a lot of success. And it really takes a fresh look at really very, very interesting papers in the 1950s and 1960s and so on in sort of cognitive psychology, and even looks at different disciplines in humanities and seeing what can we learn from the past that can inform current AI approaches in the era of big data. So this really special topics course where we will read a lot of very interesting papers and look at fresh perspectives from different disciplines and really critically reflect on what all these perspectives really mean for the current age of deep learning and AI. And this is really important if we are to really take AI forward and build on the great advances that have been made. We really need to revisit the past and look at other disciplines and take in fresh perspectives. So this is really going to be this is a special topics course, which means that I have a list of different papers that we will all read through and we will reflect, and then you will write up on that at the very end. And I have an indicative list of papers on a website, but if any other paper catches your fancy that is broadly within this topic, please reach out to me and we will work together to, if you're really interested, we can pick that paper also, as long as it's broadly within the sort of this framework or ambit of unconventional approaches. And really, this is looking at sort of the heritage of computing and the rich interdisciplinary past of AI, and seeing what new approaches can we come up with. It's really important that we learn these lessons from the history of AI, what worked and what did not work, if we are really to avoid another AI winter. And these will really reflect on these approaches and see if we can design new techniques for explainable AI. So just to give a very brief example, for example, how do humans reason? We are always told of these kinds of eureka moments, like Archimedes and Newton, like an apple fell on his head and he thought about gravitation. In reality, we are always building on the work of others. There's a preparation stage, there's an incubation stage, probably years and years of waiting, and then all of a sudden there's a moment. Naturally, scientists only remember that moment and really do not remember like all the years of preparation and incubation that has gone into that. One big example is Auguste Kekule, who came up with the structure of benzene. It is said that he was dreaming one night about a snake that was trying to eat its own tail. And from that, apparently, he woke up from his sleep and sort of had the idea that carbon atoms could be linked in a ring, because sort of previous to that, there wasn't a good structural sort of explanation for how benzene, or what is the structure of benzene, for example. So here's how there are some very interesting insights into how human brains work that cognitive psychologists and other disciplines have looked at. We will just take a look at those. And this is really, this is how computer science came about. Like perceptrons were sort of invented by people in other disciplines who just happen to be interested in computers. And it's just one sort of fresh perspective. We'll be looking at sort of computational models of creativity and other kinds of models also. Critical to how humans sort of explain things to each other or how humans reason is the fact that we create narratives and stories. So we will look at computational models of building stories and narratives. We'll look at computational models of creativity and insight. Another key factor in human creativity is how we build on analogies. So we draw analogies with things that we know. I'll give you an example on the other slide, on the next slide. There's a rich function of dreams in sort of human brains. There's a function of dreams that have been multiple hypotheses. We can read one particular paper on what is a favored hypothesis now. And another big sort of factor in human creativity is what's called common sense reasoning. Again, I will give you a few examples in the next few slides. So let's look at analogy, for example. So when we were in school, the way that we were taught about atoms, like the nucleus and the electron going around it, is that we were told that this is very similar to or analogous to how the solar system actually works. So there's a sun, there are multiple planets, they're orbiting it. So human beings are taught in terms of analogies that this situation is similar to that. And this is really critical for potentially even human engineered artificial intelligence systems. There have been steps that have been taken towards building analogies in sort of AI, but what would an approach that combines analogies with big data actually look like? So we'll reflect on that. And analogies really go to the core of sort of human creativity and insight. So about 1,000 years back, one of the great teachers of Zen Buddhism came up with this parable called the 10 bulls. And essentially, it's a story told in sort of either text and pictures that there's this farmer who has lost a bull and he's been really troubled by it. He goes around and travels to sort of distant lands, crosses a mountain, crosses rivers, but is really trying very hard to track down this bull. And then there comes a stage when he sort of perceives, as he looks at the sky, and it's a very nice day, the sun is warm, a mild wind is blowing, and he can see the trees on the distant horizon. He can get a sense that where that bull really is. Can you think of what the bull represents? If you really think about it now, in this case, this Zen Buddhist teacher is actually comparing the bull to the human mind. He's really telling us that the human mind is like a bull that's really very, very hard to control and bring it under our control. But if there's a process, if we really sort of surrender ourselves to our circumstances and accept it, then perhaps this bull, this mind, can be tamed. So in a few sort of sentences, you can see how human beings can create complex narratives and create analogies and create this sort of overarching sort of arc that is probably unique to humans. What can we learn from these systems that can inform future artificial intelligence systems? So again, this is something that we will reflect on. There are concrete aspects of this that potentially could be folded into sort of explainable AI systems. We'll also look at these approaches. For example, there have been lots of work looking at the social sciences and seeing how looking at these disciplines, how they think about explainability, and whether there are concrete ways in sort of learning from those disciplines and creating new explainable AI algorithms. We will also look at lots of literature on how we can work with domain experts and build explainable models. Human beings also use what's called case-based reasoning. We look at specific examples in the past that informed our decisions, and we look at those particular cases to really generate explanations. That's called case-based reasoning. So again, there are multiple papers that we will review in sort of these approaches. And really the idea is to really distill the essence of human creativity and intelligence, if it's possible, in a few months to do that, and really see what we can learn. So we'll have lots of fun with it. We will look at computational models of creating analogies, for example, how we build qualitative reasoning models. For example, even before we knew equations of physics, we knew how water beyond a temperature could be made to boil, or beyond a certain temperature, it could this container that's in that could potentially explode. So these are called qualitative process models, building blocks for common sense reasoning, even without having sort of physics equations underneath. That's how many animals actually reason, not only humans. We will also look at collective intelligence. So what does it mean? For example, when I look at the window, I see sort of a flock of starlings that just self-organizes, and there's a flock. This is quite interesting because there is no sort of leader in this case, but still there is sort of a collective intelligence that emerges from this ensemble. So we'll look at what it really means to be intelligent. And recently, people have made concrete steps towards quantifying that. For example, there's the abstraction and reasoning corpus now that looks at specifically creating benchmarks for quantifying intelligence, and we'll read some papers around that as well. So I have a list of just a starting list of papers in this sort of URL. Check out this GitHub repository. And if you have any other suggestions for papers, please reach out to me. I'm really looking forward to having all of you here, and we'll have lots of fun. And again, just on the side, if you want to also learn about Zen Buddhism, that's another great sort of output from this course. So together, I'm hoping to have lots of fun with you and talk with all of you soon. Thanks.